right, y'all. Today I want to teach you how to use vertical angles to find missing angles. If you would, please make this the title on the next free page in your math notebook. After you have done that, mark that page with your pencil, close it up, and really think. We're going to get into some big stuff today. All right, let's do a review from yesterday. Today we're going to learn about vertical angles, a new category of angle. Yesterday I learned about adjacent angles, complementary angles, and supplementary angles. Let me give you a quick reminder of what those are. Adjacent angles are any two angles that share a side and a vertex. So for instance, if I just draw like two angles like that, I'll just label them, A and B. Here, A and B are adjacent angles because they share this side and this vertex. Adjacent really just means like next to in the English language, and they're just next to each other angles. They share a side between them. Complementary angles are special adjacent angles. They are adjacent angles that combine to make a right angle. So we did problems yesterday where if we knew this was a right angle and we had one of the two adjacent angles and we knew that that was maybe 20 degrees, we could use that to figure out the measurement of this, because since they made a right angle together, we knew together they would be 90 degrees. Supplementary angles work the same way. They're also special adjacent angles. They're next to, they share a side and vertex, but they make a 180 degree or a straight angle together. So that would be something like, these two. And so same thing yesterday, we might say, okay, well, we know this one's 50 degrees. What is this? And we know that they were 180 together, so we could use that to figure out that this would be 130. Something like that. So that's adjacent angles, complementary angles, and supplementary angles. Today we move on to vertical angles. So let me just start even by telling you what those are. Vertical angles are created at the intersection of two lines. So this is going to be tricky for me to draw these like just right. It won't be that bad. So if you think about like a line going like that and another line, let me get it right where they meet kind of in the middle. Another line maybe going like this. The vertical angles are the ones across the vertex from each other. So that would be like this one and this one. Those are called vertical angles from each other. They're across the vertex from each other. So that's what we're talking about today. Those kind of angles right there across. So I want you to explore them a little bit. I have this link to the same site as the last lesson in the description of the video here. And what I want you to do is, I gotta pause and expand my screen. Hang on. You're gonna visit this site, same one as yesterday. And up here you can switch it to intersect here. And so I want you to explore vertical angles with this. So you'll notice I got a random set. Remember, vertical angles are when two lines intersect like this and they're across the vertex from each other. So like this 71 and this 71, this 109, this 109. So look at a few sets of vertical angles and start to see what you notice, and unpause back to the lesson when you're ready. Take your time. Okay, so what I hope you noticed is that in all of those examples, the vertical angles always have the same measurement. You can see some in my window here, right? Here, the 67s are vertical angles. They have the same measurement. The 113s are also vertical angles. They're across the vertex from each other, and they have the same measurement. Do another one. 72 and 72, 108 and 108. What I also hope you maybe notice is that, I can't really draw on this because I'm on somebody else's thing, but you'll notice in addition to the vertical angles here, you can also see supplementary angles. This 108 and this 72, they make supplementary angles along this line. They would add up to 180. Same thing here. The 104s are vertical angles. The 76s are vertical angles. If you put a 104 and a 76 together, you get a straight angle here, and those two would add up to 180. So those facts are going to be really important today, and that's a biggie about vertical angles. I'll have that back up on the screen for you to write down. They have the same measurement. So when we look at, say, a simple problem involving vertical angles like this, if angle AED is 95 degrees, find the measurements of all the other angles in the diagram. So there's ways you can do this, but let's start with what we know. Angle AED is 95 degrees. We're going to use just that one fact to find all of the other ones in the rest of the diagram. There's multiple ways you could go about this. There's multiple paths you could follow. I'll follow two just to kind of show you how you could end up doing this. So one way you could do this is you could use vertical angles like we figured out today and say, okay, since I know that AED is 95 degrees, I would also know that CEB, this one down here, also has to be 95 degrees because those are vertical angles. So I can say I know that angle CEB equals 95 degrees. I know that because it is vertical to angle AED. That's like my justification, or in science we kind of sometimes talk about arguments and evidence and reasoning. This is sort of my reasoning and my evidence here, so to speak. So I know this and this angle, since they're vertical angles, they have to be the same. So now what about the other two? Well, notice any two adjacent angles I pick, like say this one and this one, or this one and this one, or any other two that are adjacent to each other, since they're along a line, they're going to be supplementary angles. So I know that this CEA one right here, if this is 95, this must be the rest to make it 180, which I think is 85. Let me do the math on that. So I know that this angle and this angle together are 180, and that's 95. So 180 minus 95, I think it's going to be 85, but I should check. Be really sure. 517 minus, yeah, 85. So now I know that angle CEA is 85 degrees. How do I know that? I know that because it is supplemental to, it's from yesterday, to angle AED. It makes a straight line with angle AED. Now I can find this last one a couple ways. I can make another supplementary set here, or I can just say, look, this is 85 and this one's vertical to it, so it must be 85 as well. That CEA and that BED, they're both supplemental. So now I can finish off by saying angle DEB is equal to 85. How do I know that? It is vertical to angle AEC. So that's one way I could have done it. I also could have done this with no vertical angles whatsoever. I'm not going to go way into this, but I also, I put method 1, method 2. I don't have to do that. If I know this is 95, I could say, oh, well, look, these make a straight line, so that's 85. And then I could say, oh, look, these two make a straight line, so that's 85, so that must be the other 95. And then I could say, oh, look, these make a straight line, they're supplemental, so that's 95, that must be the other 85. There's different routes you can take to get to the answers in these kind of problems without anything too wild. So let's look at a more advanced one here. So check this one out. If angle HJK is 35 and angle FJI is 95, what is the measurement of angle KJG? Woof, it's a tough one. That's a lot. So looking at that, we've got to be able to figure out that one little angle here, and this is more advanced because if you look, there isn't an obvious vertical angle for this 35 because of this thing in the way. So what I do notice is this. If I kind of ignore this segment JK for a minute and look at this angle, this full angle, and this full angle right here, those are vertical angles together. If you ignore this, if that weren't there, those would be vertical angles because they're on the opposite two sides of where two lines intersect. So what I do know, first thing I'm going to say that I know is that angle HJG, ignore that middle part, HJG, if this weren't here, that's equal to 95 degrees because it is vertical to angle FJI. So I know that full thing is 95. So I know that this one I'll mark it in a new color, that I'm marking in green, that's equal to 95 degrees. And if that's equal to 95 degrees and this part of it is 35, its adjacent angle here that's missing is the rest. So 95 minus 35 is 60 degrees, I believe. So that's the last thing I need to know. Angle KJG is 60 degrees. How do I know that? I know that because when I don't know how to word this right. So I know that because angle HJK and angle KJG together are 95 degrees. And so that 35 came out of there. So it's all kind of like a puzzle. You've just got to look and say, okay, where can I find complementary angles? Where can I find supplementary angles? And where can I find adjacent angles? And where can I find vertical angles? It's a lot to keep track of, but when you do, it's just like putting a puzzle together. Like if I go back to the very beginning on this one, you know, which we know some information. We know this is 95. We want to find this. We're like, okay, well, I know this and I know this, so I can use that information to find this. Kind of tricky. So that's a lot of I do because these vertical angles get advanced like really, really quick. So what I'm going to do here, I cap out at 15 minutes and I'm at 12. So what I'm going to do is stop this video here, and there's going to be a part 2 that you can use to write your we do's down. So I'm going to pause this one here, and I need you to go on to the next video to finish up with the we do examples.